Okay, now we're going to look at the second method for calculating probability, which is called the empirical or relative frequency method. So this method of probability is calculated by conducting an experiment and taking the frequency from the experiment and dividing it by the number of trials. So the probability of an event A is equal to the number of times that A happened divided by the number of trials of the experiment. So we're going to actually perform an experiment. I'm going to use a virtual die. So on the left hand here, I have a website, random.org. This is a great website if you need to do any sort of probability experiments. They've got a lot of different ways to run experiments. I'm going to see if I can just resize this real quick though. I don't like that, just kidding. So I have up the dice roller, and this rolls the dice just as randomly as it would if I was actually rolling the die myself. So you and your friend are playing Trouble. In the game Trouble, you have one fair die that you roll on your turn. To start playing the game, and in order to move your first piece, you must roll a 6. So we're going to conduct an experiment to find the probability of rolling a 6 by rolling a die 20 times and recording the results. So instead of just thinking about what the probability would be by using our knowledge of how many outcomes there are on a die and how many of those outcomes are a 1, like we would in the classical method, we're going to actually conduct an experiment to see what we get. So I'm going to roll the die on the left side, and then over here on the right side, I'm going to keep a tally of what the outcome is. And I'm just going to zoom in on this box a little bit more. So here we go. So we're going to roll again. So we got a 5. Roll again. Another 5. 2. 3. 1. 4. 6. 1. 3. 1. 4. 2. 2. 2. 3. I gotta see how many I've done now. 3, 7, 10, 11, 12, 13, 14, 15. All right, we've got 5 more rolls. 4. 1. 3. 1, and now I think that's it, right? 9, 13, 14, 15, 16, 17, 18. Oh, one more roll. 5. All right. So I've conducted my experiment. I've tallied up each of the outcomes that I saw. And now I am interested in the probability of rolling a 6. So for me, the probability that I roll a 6 is going to be how many times did I roll a 6? So I saw 1 6 out of how many total times did I conduct this experiment? We ran this experiment 20 times. So 1 divided by 20 gives us 0.05, or roughly 5%. So pretty small chance that I get a 6 based on this experiment. And this is how relative frequency probability works. You run the experiment, and that's how you calculate the probabilities. So then a second piece to go along with this is the law of large numbers, and I am going to change the size of the screen at this point. So the law of large numbers says that as the number of trials in a probability experiment increase, the relative frequency probability of an event approaches or gets closer to the theoretical probability of that event. So what this means, well, let me reread it first. So as the number of trials in a probability experiment increase, the relative frequency probability of an event approaches the theoretical probability of that event. So now what this means is, if we were to continue rolling the die over and over and over again in this experiment, and instead of only doing it 20 times, we did it 200 times, the probability that I roll a 6 would get closer and closer to the theoretical probability of rolling a 6. And the theoretical probability of rolling a 6 is there is 1 6 and 6 outcomes, which is 0.1667. So this experimental probability with only 20 repetitions was 0.05. But if I keep running this experiment over and over and over, I keep rolling the die, I'll see that 0.05 start getting closer and closer to the theoretical probability of 0.1667. It may never be exactly that amount, but it's going to get closer and closer and closer to it. And that principle is the law of large numbers. So this is the empirical or relative frequency method for calculating probability.